Hello everyone, welcome to Maths Decoded. Today I'm solving 9709 October November 2023 paper 4-2, which is your mechanics paper. So let's get started. Question number 1 reads, a block of mass 15 kg slides down a line at greatest slope of an inclined plane. The top of the plane is at a vertical height of 1.6 meter. The speed of the block at the top is 2 meters per second, and the speed of the block at the bottom is 4 meters per second. Again, I said in my previous videos as well that it's better that you draw out diagrams in paper 4. So you have a mass of 15 kg, and it says that the speed over here is 2, the speed over here is 4, this height is 1.6, and that's pretty much it about what is given to us in the question. Um, Over here, we can use, now you know one thing that over here this block has a height, which means that it has some kind of a potential energy over here. And then it starts moving downwards. So the height is decreasing. When the height is decreasing, it means that there's going to be a loss in the potential energy. And because it's moving, it's in motion, there's going to be a gain in kinetic energy. So potential energy is going to go down and kinetic energy is going to go upwards. So for this, we will use an equation that is loss of potential energy is equal to the gain in the kinetic energy plus the work done against resistance. And this is basically what they want us to find out. This is what we need to find out. Anyways, let's work on the loss of potential energy first. The formula for potential energy is mgh, where m is the mass, 15, into g, that is 10. In mechanics, you will always be taking g to be 10, and h, that's 1.6. Remember, the height is always going to be the vertical height. You can't take this length. It's not given to us in the question, but I'm just saying it anyways. You can never be taking this height. This will come out to be 240 joules. Let's talk about the gain in kinetic energy. The formula for this is half m v square minus u square. So half into m, that's 15, v is 4 square minus u, which is 2 square. This is going to come out as 90. Now, using this equation over here, I am going to subtract. So you had potential energy is equal to kinetic energy plus resistance. Work done against resistance. So potential energy minus the kinetic energy is going to give you the work done against resistance. That's going to be 240 minus 90, which is going to give you 150 joules. All right, moving on to question number 2. It reads, the diagram shows a smooth ring R of mass mkg. Now this tells me that this question is about rings and rods. Threaded on a light and extensible string, a horizontal force of magnitude 2 Newton acts on R. The ends of the string are attached to fixed points. All right, it tells you the angles, and it tells you that the ring is in equilibrium. Find the tension in the string and the value of M. Over here, you need to realize one thing, that the tension in this string is going to be equal to the tension in this string. Why? Because whenever you have a movable ring, the tension is always going to be the same in both the strings. So this is basically, you're going to solve this question using an approach towards coplanar forces. I'm going to draw a dotted line over here along the horizontal, and I know that this is 90 degree. So this is going to be 180 minus 90 minus 30. That is going to give me 60 degrees over here. Similarly, I know that this is also 90 degree. I'll do 180 minus 90 minus 40. That's going to give me 50 degrees over here. I hope that makes sense. Now I'm going to break down my forces into components, and it's always better that you draw a separate diagram for this. Let's say this is your ring. It has a mass of m kg, so the force acting downwards is going to be 10 m. Then you have a horizontal force, that's 2 newtons. Then you have these component forces. So I know that the angle, that the component with the angle is going to be cos. So this is going to be t cos 60, and this is going to be t sine 60. Similarly, I know this angle is with the this side is with the angle, so this is going to be t cos 50, and this is going to be t sin 50. Now I know that I can put the horizontal forces equal to each other, and that's what I'm just going to do. So 2 is equal to t cos 60 plus t cos 50. I'm doing this because I know that it's an equilibrium, which means the horizontal forces on the right are equal to the horizontal forces on the left, and likewise with vertical forces. Anyways, so basically, if I solve this out, it's going to give me t as 1.7501. All right, now I'll solve the um, vertical forces, the vertical forces. So this is going to be put equal to these two things. So t sine 60 is equal to t sine 50 plus 10m. This is going to be, I'm basically going to substitute the value of t over here. That's going to be 1.7501 into sine 60 is equal to 1.7501 into sine 50 plus 10m. This is going to give me the value of m to be 0.017 kg. Also, one more thing before I move forward. Whenever it says find the tension in the string, it means that you are going to write down the unit with it. That is newtons. But when it says you to find the value of m, you are not going to write the unit with it. It's not, I'm not going to write kg over here. It should just be 0.07 because they're telling you to find the value. If they said find the mass, then you're going to write down kg with it. But when it says value, you are not going to write down the unit with it. All right, moving on to question number 3. It says a block of mass 10 kg. So the diagram is drawn here for you. You won't have to draw it yourself. A block of mass 10 kg is at rest on a rough plane inclined at an angle of 30 degree. A force of 120 Newton is applied, which is shown over here, to the block at an angle of 20 degree above a line of greater slope. Now I need you to stop over here and annotate on the diagram before you move any forward. This is going to break down into two components: 120 cos 20 and 120 sine 20. Now let's resume. There is a force resisting the motion of the block, and 200 joules of work is done against this force when the block has moved a distance of 5 meter up the plane from rest. Rest means that u is equal to 0. And s over here is given to us as 5. Find the speed of the block when it has moved a distance of 5 meter up the plane. Now, if I need to find out the speed, I need to know the acceleration of the block, which is not given to us over here. It means that we will have to figure out the acceleration before we plug all of this information into a SUVAT equation. Now I know that it has a mass of 10 kg. It means you will be having this as 10 cos 30 and 10 sine 30. I do not know the magnitude of this force, and that's what I'm going to find out first. So it says work done is equal to force into the distance. You're supposed to be familiar with this formula. Work done is 200 joules, and the distance is 5. That's going to give me the force as 400 newtons. It is basically a resistance force, and the block is moving up. If the block is moving up, the resistance force is going to be in the opposite direction. That means I'm going to apply this force in this direction. That's actually, it's going to be not 400, it's going to be 40 newtons. All right, so now I'm going to use F is equal to ma. F is equal to m into acceleration. The resultant force in this case is going to be 120 cos 20 minus 10 100, actually 100 sine 30 minus 40. I hope that makes sense. I basically took this force and I subtracted these two forces from this. That's going to give me the resultant force. The mass is 10 and the acceleration is something that we are trying to find. This is going to give you the acceleration as it's going to be 2.2 0.276. Now that we have the acceleration, I have u that is 0. I know s is equal to 5. I need to, what do I need to find out? I need to find the final speed. V is something I need to find out. So I can use the formula v squared equals u squared plus 2as. V is equal to under root of u squared plus 2. A is 2.276 and S is 5. So V comes out to be, just give me a second. It comes out to be 4.7707. You round it off to three significant figures. By the way, all of your answers are supposed to be the three significant figures except for angles. Angles are always going to be one decimal place. It is going to be 4.77. Yes, you can write it down in brackets. All right, moving on to question number 4. It says a particle P of mass 0.2 kg lies at rest on a horizontal rough plane. So it's not an inclined plane anymore. It's a rough plane. It's a horizontal plane. I'm going to draw out a diagram. This is 0.2 kg, and it says it's a rough plane. A rough plane means friction is present. A horizontal force of 1.2 Newton is applied to P. Given that P is in limiting equilibrium, find the coefficient of friction. All right. So I'll draw a 1.2 Newton force over here, and I know that it has a mass of 0.2 kg, so the force will be acting downwards. That will be weight is 2 Newton. And I also know that a normal reaction force acts upwards. Now, I know that friction is going to be, F is going to be 1.2, and R is equal to 2 Newton, upwards equals downwards. So we're going to be using the formula F is equal to mu R. Mu is going to be F divided by R, that's 1.2 divided by 2, and that is going to give me 0.6. Moving on to part B. Given instead that the coefficient of friction between P and the plane is 0.3. So mu, the value of mu has been changed now. Find the distance traveled by P in the third second of its motion. All right, so let me redraw the diagram over here. 1.2 Newton force, 0.2 kg mass, so 2 Newton acting downwards, R acting upwards. Okay, now it says that the coefficient of friction is changed. So that is going to mean now you need to understand that R is going to be still 2 newtons and mu is 0.3. So I can figure out F. F is equal to mu R. So F is going to be mu 0.3 into R, that is 0.6. So mu as the value of F is now 0.6. F is always going to be acting in the direction opposite to the direction of motion. So it's going to act in this direction. That's going to be 0.6. Now using this, I can use F is equal to ma to figure out the acceleration. The resultant force is going to be 1.2 minus 0.6 divided by the mass. The mass is 0.2. That gives me the acceleration as 3 meters per second squared. Now I can use Suvat equations to figure out the distance in the third second of its motion. Now, there's one thing you need to understand that if it says third second of the motion, you are basically going to be doing, you are basically first going to figure out T3, the value of S at T3, and then the value of S at T2. And then you're going to subtract these two values. So let's figure that out. S equals um, ut plus half at square. This entire thing is going to be 0 because u is 0. So s is equal to half, a is 3. First, I'll take t to be 3 square. That's going to give me a value of 13.5. Then I'll take t to be 2 squared. And that will give me a value of 6. And then I subtract these two values. That's going to give me 7.5. So I did s at t is equal to 3 minus s at t is equal to 2. That gives me the value of the distance traveled in the third second of its motion. Alright, moving on to question number 5, it says a particle A of mass 0.5 kg is projected vertically upwards From horizontal ground with speed 25, find the speed of wave when it reaches a height of 20 meters. Um, I know that acceleration equals minus 10. I know s is equal to 20. I know u is equal to 25. I can easily figure out v. The formula I'll use is v squared equals u squared plus 2as. V is going to be u squared plus 2as. Just plug in the values. U is 25 squared plus 2, A is minus 10, and S is 20. This is going to give you V as 50. Then it says when A reaches a height of 20 meters, it collides with a particle B of mass 0.3 kg. All right, let's draw a diagram for this. So let's say this is horizontal ground. You have A that is moving upwards, and you have when it reaches a height of 20 meters, it is colliding with a ball B that is moving downwards. This question is related to momentum actually. Anyways, particle B of mass 0.3 kg, which is moving down in the same vertical line with the speed 32.5. In the collision between the two particles, B is brought to instantaneous rest. Means that this velocity becomes zero at the end. Show that the velocity of A immediately after the collision is 4.5. All right, I know in this question, a momentum question, you have to define whether you're taking upwards as positive or whether you're taking downwards as positive. And I'm going to be taking upwards as positive. So I'll use the formula m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So the mass of A was, what was the mass? 0.5. 0.5 into u1, which was 15, as we found in the first part, this. M2, that is the mass of B, that is 0.3, into its initial velocity, which is 32.5. Now remember, it is moving downwards. It's moving downwards, and the downwards velocity we have taken to be negative because we've taken upwards as positive, so downwards is negative. So I'm going to write negative 32.5. Then is equal to m1, that is 0.5 into v1. This is something we need to find actually. And we do know that after the collision, A will start moving downwards. So we'll take it as negative x plus m2. M2 is the mass of B, that's 0.3, and the final velocity of B is 0. So I'll write this as 0. Anyways, when we solve this, it's going to come out as negative 2.25 is equal to negative 0.5x. Negative negative gets cancelled, and x comes out to be 4.5 ms minus 1. Alright, moving on to part C, it says find the time interval between A and B reaching the ground. You should assume that A does not bounce when it reaches the ground. Alright, first let's have a look at A. For A, we know that S is equal to 20, U is equal to 4.5, as we found in the first part, in the second part actually. And acceleration is 10. So we will use the formula S is equal to ut plus half a t squared. S is 20. U is going to be 4.5 t plus half. A is 10 and t squared. That's going to give me t as 1.6. Next, we'll talk about B. B has a u of 0, S equals 20, acceleration equals 10. So S equals ut is going to become 0 because u is 0, half a t square. This cancels out, it becomes t is equal to 2. Now you'll just subtract these two values, 2 minus 1.6, because we want the time interval. So that is going to leave you with 0.4 seconds. Alright, moving on to question number 6. It says a railway engine of mass 120,000 kg is towing a coach of mass 60,000 kg up a straight track. inclined at an angle alpha to the horizontal, where sine alpha is 0.02. Alright, first things first, draw a diagram. This is alpha. It says I'm moving up. So we're going to be taking this as the 120,000 kg mass and the coach of mass 60,000 with a string in between. It says the driving force produced by the engine, this is the engine, is 125,000 newtons, and there are constant resistances to motion of 22,000 newtons on the engine and 13,000 on the coach. So 22,000 here and 13,000 here. All right. Now we know that their masses are, so this is going to become 120,000 G cos alpha. We don't need these components actually, we just need the horizontal components. So 120,000 G sine alpha and 60,000 G sine alpha. We also know that there will be a tension acting in the string, and yeah, that's pretty much it about it. Now let's try to solve this. Um, I'm going to be solving this question using the forces acting on the entire system. So we know that there is a forward force of 125,000 Newton minus all these forces acting over here. That's going to be minus 120,000 G sine theta. I can just plug in the values. I think G is 10. Sine alpha is 0.02 minus this value 60,000 G sine alpha, that's 0.02 minus the resistance forces now, minus 22,000 minus 13,000. This entire expression gives us the resultant force. um, this comes out to be 5,400 actually, 54,000. Now I'll use the formula F is equal to m into acceleration. I know this is 54,000 divided by the masses. The masses will be taken off the engine and the coach. 120,000 plus 60,000. That's going to give me the acceleration. Acceleration is going to come out as 0.3. So we found the acceleration. We've done half the question. Now let's find the tension. They want you to find the tension in the coupling. The tension in this is the value of tension that they need you to find out. So let's take the forces acting on this. That is going to be 125,000 minus 120,000 G 0.02 minus tension minus the resistance force acting on it, that's 22,000, is equal to mass into acceleration. The mass is, I just write down it over here. Mass is 120,000 into acceleration we found in the previous part, 0.3. This is going to give me the value of T as 43,000 newtons. Alright, moving on to part B, it says at an instant when the engine is traveling at 30 meters per second, it comes to a section of track inclined upwards at an angle beta. The power produced by the engine is now this, and as a result, the engine maintains a constant speed. Constant speed means that there is zero acceleration. So again, I'll draw a diagram. The angle over here is now beta, and this is your engine. It's connected to your trailer. Um, the mass was, I guess, 150,000 into G cos beta and 150,000 G sin beta. Similarly for this, 60,000 G cos beta and 60,000 G sin beta. And it says that the resistance forces are unchanged, so that's just going to be 22,000 and 13,000 if I'm not wrong. Now, in this case, you are not given the driving force. So that's what I'll try to calculate over here. The power is 45. Just write down the formula. Power is equal to driving force into velocity. Power is 45, 0, 0, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 divided by the velocity, that is 30. That's going to give you a driving force of 150,000. So you now have a driving force of 150,000 newtons. Again, we'll work out the resultant force the same way. 150 forward forces minus the backward forces. That's going to be 150,000 G sine beta minus 22,000 minus 12. Um, Actually, I think that, yeah, my bad. This was not 1,500, this was 12. 120,000. 120,000. And this was also 120,000. Anyways, so minus 60,000 G sine beta minus the resistance force on this, 13,000. Yeah, this is going to be the resultant force. The formula is F is equal to ma. The acceleration over here is 0, so this entire thing becomes 0. So F is basically going to be equal to 0. So I put this entire expression equal to 0, and let me just write it down. In fact, I can just write down 0 over here is equal to 0. If you solve this, it comes out to be beta is equal to 3.7 degree. Remember, angles are always one decimal place. Alright, moving on to question number 7. It says a particle x travels in a straight line. The velocity of x at time t seconds after leaving a fixed point O is denoted by v. The acceleration of x is 0 at t is equal to p and t is equal to q. Find the value of p and q. So you are basically now for these type of questions, I have made a small mnemonic, and that is don't drop very dangerous appliances. It helps you remember the entire pattern. This is distance, this is velocity, and this is acceleration. So you have to go from distance to velocity, it's differentiation, velocity to acceleration, differentiation. But if you have to go the other way around, like if you invert the directions, then it's obviously going to be integration. It basically helps you remember this entire phenomena easily. Talked about acceleration, so I need to convert this velocity equation to acceleration. So I will basically differentiate it. So dv over dt is going to be equal to negative 0.3 t square plus 3.6 t minus 6. I know that this is equal to 0 because the set acceleration is 0. So um, you can just put this entire thing into your calculator, or you can solve it by middle term breaking, or by the use of your quadratic formula. I just put it into my calculator, and I will get p is equal to 2 and p is equal to 10. T is equal to 2 and t is equal to 10. Now they told us that q is supposed to be the bigger one, so I'll say that q is equal to 10 and p is equal to 2. Let me know if you need a tutorial on how to solve quadratic equations directly into a calculator. Alright, moving on to part B. It is given that the velocity of x is 0 at t is equal to 14. Um, Find the velocities of x at t is equal to 2 and t is equal to 10, and hence sketch the velocity time graph for this motion. All right. So that basically means that first of all, I need to figure out the velocities at these points. So let's say what was the equation? Let me just copy it down over here. Velocity is equal to negative 0.1. We need to figure it out at t is equal to 2, so I'll just plug in 2 cube plus 1.8, 2 square minus 6 into 2 plus 5.6. This is going to actually give me 0. Now let's do it at 10, negative 0.1, 10 cube plus 1.8, 10 square minus 6 into 10 plus 5.6. This is going to give me 25.6. Now let's sketch a graph. Sketching a graph is actually pretty simple. Time per second and make sure that you label the axes. So I know that from this equation I can tell that the y-intercept of the graph is 5.6. So I'm just going to label this as 5.6. Then I know that when time is equal to 2, my velocity is 0. So let's say this is 2. My velocity is basically 0 at this point. Then I know that when my velocity is 10, when the time is 10, the velocity is 25.6. So let's say 25.6 is somewhere over here. So I'll mark this point. And then I know that when my time is 14 seconds, I know my velocity is again 0. And I don't know about 15 though. 15 is something that I don't know. So I'll have to figure it out. I'll just plug in t is equal to 15 into my equation. That's going to be negative 16.9. So it's a negative value. I can just mark it somewhere here. Now you're just supposed to connect the dots. My drawing is a little bad. By the way, this is supposed to be a smooth curve. I'm doing it on a screen, so that's why it's a little not good looking, but make sure that it's a smooth curve. It doesn't seem like that you've connected these dots dot to dot. Uh, Anyways, moving on to part C, it says find the total distance traveled by x between these two times. All right, so the equation I was given was a velocity equation. Let me write it down here again. All right. I was given a velocity equation. They want me to find out the distance. Let's see what I have to do for this. So velocity is given to me. I just use a different color. I need to find out the distance. So I'm moving from here to here. It means I have to integrate it. So integral of negative 0.1 t cube plus 1.8 t square minus 60 plus 5.6. The limits I'm having are 15 and 0. Now, there's one thing you need to understand, and that is that if you have a look at your graph, your values of the distance are positive in this entire region. So from 0 to 14, they're positive. But from 15 to 14, you have a negative value. So you'll break down your integral into two parts. Let me integrate this expression once. If you need help on integration, you can let me know in the comments. So I'll be breaking this down into two parts. One part is going to be calculating the distance from 14 to 0, and the other part is going to be calculating the distance from, just give me a second, let me rewrite this, 15 to 14. And why am I doing this separately? I'm doing this separately because this entire value is going to give me this entire expression is going to give me a negative value. So I'm going to put a negative sign behind it so that it turns the final value into a positive. Anyways, we're basically going to be, you can plug this directly into your calculator, or you can do that to check, but you need to show the steps, all the steps in your working. You're basically going to be plugging in 14, and then you're going to plug in 0, and then you're going to subtract those two values. And that value is going to be coming out as 176.4. Similarly, in this expression as well, you're first going to plug in 15, you're going to get a value, then you plug in 14, you're then going to get a value, and it's going to be negative value. That's why I put a negative sign over here, which is basically going to be negative 8.025. Um, that's going to become 8.025. Now I'll add these two values. If you by any chance need help on how to integrate within a calculator, you can let me know down below and I will respond to you on that. Anyway, so the final answer comes out to be 184.425 meters. And with that, we come to the end of this paper. I hope that this video was helpful for you.